Good afternoon, everyone. Once again, I am not able to be in class today due to me being on site for tag testing, but I did decide to record a lesson for you all. So we're going to get started with our Behringer question, and this is going to be the way that you receive your credit for class today. So if you plan to be marked as present, you will need to respond to this question in the Teams chat. So take a few moments to pause at this point and answer the Behringer question in the Teams chat. And it asks, when you hear the word charge, what comes to mind as related to science? So again, take a few moments to pause, answer that question in your own words. There's no right or wrong answer, so no need to Google, and then we'll continue. On our agenda today, we are going to briefly go through our procedures and announcements. Today, we're going to be taking a look at charge in our mini lesson, and then you'll spend the remainder of your time working on your assignments in Canvas. And with our announcements, on Monday, we are going to have a teacher PD day, so there'll be no school. And the class meetings announcement is just you are going to have the rest of your classes this week in Microsoft Teams, but that will not apply to this class since I won't be here this week. And with our assignments and due dates, we have our 06.02A Conductors and Insulators quiz due tomorrow, so please be sure you get that completed this week. And if you have not yet completed your 06.01 Force Fields discussion, that was due on yesterday, so go ahead and get that submitted as well. Our standard is S8P5B, where we plan to carry out investigations to demonstrate the distribution of charge in conductors and insulators. As we continue in our magnetism and electricity unit, our learning target states I can identify methods of charging. So today we're going to be looking at charge. So first we're going to quickly review matter. And we know that matter is anything that takes up mass as well as space. All matter is made up of atoms, and an atom is just the simplest form of matter made up of protons, neutrons, and electrons. So those are those protons, neutrons, and the electrons. When the protons and electrons are equal, the atom is considered electrically neutral. If electrons move, it can create an imbalance of charge, causing static electricity. So next we're going to watch a video about what is static electricity. I'll provide you all the link to this video if you want to watch it independently, but I'll also play it for us in class.
It can strike without warning at any moment. You may be walking across the soft carpet and reaching for the doorknob when suddenly, zap. To understand static electricity, we first need to know a bit about the nature of matter. All matter is made up of atoms that consist of three types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in an atom balance out, which is why most matter you come across is electrically neutral. But electrons are tiny, almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged, while the one with more electrons accumulates a negative charge. This situation is called a charge imbalance, or net charge separation. But nature tends towards balance. So, when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they're most needed, either jumping off the negatively charged object or jumping onto the positively charged one, in an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static discharge, is what we recognize as that sudden spark. This process doesn't happen with just any objects. Otherwise, you'd be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist using its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap, the metal doorknob's loosely bound electrons pop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature. In certain conditions, charge separation will occur in clouds. We don't know exactly how this happens. It may have to do with the circulation of water droplets and ice particles within them. Regardless, the charge imbalance is neutralized by being released towards another body, such as a building, the earth, or another cloud in a giant spark that we know as lightning. And just as your fingers can be zapped over and over in the same spot, you better believe that lightning can strike in the same place more than once.
All right, so let's talk about static electricity. Static electricity is a charge imbalance that results in the buildup of excess electric charge on an object. When objects with loosely held electrons build up on the surface, shock results when the charge is neutralized. So think of some examples, some of which you saw in the video, of static electricity. For example, you may think about putting on a sweater as it's come fresh out the dryer, or going down a slide at a playground. You may experience some type of static electricity shock at those moments. So there are rules to charge. Opposite charges attract, like charges repel, kind of puts you in the mind of magnetism, which we discussed earlier. The law of conservation of charge tells us that charge cannot be created or destroyed, only transferred. Net electric charge is always constant. An electric field is an area surrounding charged particles or objects within which a force can be exerted on other charged particles or objects. This allows the charges to act at a distance, and the field can move the charges around an object near it. The field can also allow charged particles placed in the field to be pushed or pulled by the force exerted by the field. An electroscope is a tool that is used to detect the presence and magnitude of an electric charge. Some materials transfer electric charge well, where others do not. Conductors are those materials that allow for electrons to flow easily, readily conduct electric charge. For examples, metals, especially those contained in copper wires, as well as your skin. Insulators are materials that block the flow of electric or electrons through them. These are things like plastic, wood, air, rubber, and glass. Inside of wires tend to be metal to conduct the flow of electric charge, whereas the outside is rubber or plastic to insulate us from being shocked by the charge. There are three ways in which charges can be transferred. The first is through conduction, which is the transfer of electrons through direct contact between objects. Electrons from one object move to another object. The object must be a conductor to transfer the charge. Second, we have through friction. This is the transfer of electrons through rubbing objects. Socks rubbing on a carpet, then touching your siblings and shocking them is an example of this type of transfer. And we have induction, which is the transfer of electrons through electric fields working over a distance. The charged object is brought near a neutral object, causing polarization, and the inducing a charge on the neutral object. Static discharge is the sudden flow of electric charge between two charged objects due to the buildup of static electricity. And this is how we get lightning. The movement of the clouds and air currents cause a buildup of static electricity in the clouds. When the electrons become great enough, the positive charge is induced on Earth. And eventually, the attraction is so great that the electrons travel from the clouds to the Earth to neutralize the charge imbalance. Grounding is the process of removing excess charge on an object by transferring the electrons to another object to neutralize the electrical imbalance. This redirects the charge to the ground rather than a building. So as we wrap up, our target has been to identify the methods of charging. You all are going to be working on your 06.02a conductors and insulators quiz, as well as any past due assignments that you may have. If you have any questions, feel free to message me in Teams, and I'll be more than happy to respond to you there. I hope that you all enjoy the rest of your day, and I'll see you back on Tuesday.